Okay, 9.5 deals with solving quadratic equations by graphing. And remember, we've talked earlier in previous sections about a solution to a quadratic are the zeros of the quadratic. So we're looking for the zeros, and we call those also, another name for those is solution. So where it crosses our x-axis. So the first way we're going to solve for these is simply by graphing. So if we start here at the top, you can find solutions to a quadratic equation by looking at the graph. So let's find the solutions of x squared plus x minus 6 equals 0. And we'll talk more about setting it equal to 0. That's important. So solutions occur when the graph crosses what? The x-axis. So if I look at this graph, it looks like here and here, it's crossing my x-axis. Those look like my solutions. So it looks to be -3 and +2. Let's check those. When we check a solution, when you plug it into your equation, your answer, your y value needs to be 0 because you haven't moved up or down along your y-axis. So if I plug in -3, always put those into parentheses. -3 squared is 9. Plus a -3 minus 6. So 9 minus 3 minus 6 really does equal 0. So -3 is a 0. Now we check 2. Again, 2 squared plus 2 minus 6. Everywhere an x occurs, I plug in that value that I'm solving for. 4 plus 2 is 6 minus 6 is 0. So my zeros check out. Let's take a look at our examples that were given. And the graphs are already done for us. Here's my equation, 3x squared plus 9x equals 0, and it gives me the graph. Well, let's just circle what appears to be where it crosses my x-axis. It appears here at -3, and it appears this one is at 0 through the origin. Let's check. Let's first plug in -3. 3 times -3 squared plus 9 times -3. -3 squared is 9 times 3 is 27 plus 9 times -3 is -27. That really does equal 0. Now if we plug in 0, 3 times 0 squared plus 9 times 0. Well, 0 squared is 0, times anything is still 0, plus any number times 0 is 0. So it really does equal 0. We've talked before how many zeros you can have on a quadratic. In this case we had 2. In our example up above we had 2. So if your parabola, the vertex lies below the x-axis, it opens up, it'll cross it twice. Above the x-axis opens down, it will cross it twice. There are 2 other possibilities. Your vertex can lie on your x-axis, which will result in 1, 0, 1 solution. Or it can lie, above the x-axis and open up and not touch the x-axis at all. You'll have 0 zeros or no solution. So here it looks like it only just touches on the vertex. So I think I only have 1 solution. In fact, it only left me space to check 1 number. You guys do the check on 2, see if it works. Find your zeros here, run those checks. I'll give you participation tomorrow. If we move on to the back side, let's take a look at some of this. So we have a difference between quadratic equations and quadratic functions. The difference is very small, and I'm not going to be too picky about it this year. It comes more into play in higher level math, so we do need to talk about it. So a quadratic equation is just simply written a little bit differently than a quadratic function. So I could have any type of quadratic, x squared plus 4x equals 5. I don't have a y value in there, and that's what makes it an equation. I only have 1 variable. Or I could set it equal to 0. X squared plus 4x minus 5, I just subtracted 5 from both sides, equals 0. Those are types of equations where I just have one variable. Now I can have it to different powers, but it's just one variable. This same equation written in function form we've seen before. I'm going to use this bottom equation to turn it into function form. Function form would just be saying, instead of 0, I would say f of x is equal to x squared plus 4x minus 5. Instead of f of x, that's interchangeable with y. Now I have y equals x squared plus 4x minus 5. So very subtle differences. It means a little bit more later on. Functions we can graph because we need a y and an x to graph. An equation is something we can just solve. The graphs of either an equation or a function is the same. It's a parabola with an axis of symmetry. The zeros also are same. Okay? The zeros for a function we kind of find from a graph. For an equation we can check because it has to equal 0. So your solutions or zeros to an equation or a function are the same. It's mainly just in the notation. So let's answer these questions about functions and equations. Is y equals x squared plus 3x plus 2 a quadratic function or a quadratic equation? Does more than one variable exist in that? Yes. Quadratic function. Alright, we need to write the related function two different ways. This is an equation, a quadratic equation. We need to write the function. Very easy. I'm just going to replace this 0 with f of x and with y. So I'm just going to say f of x is equal to 5x squared plus 7x. And I'm going to say y is equal to 5x squared plus 7x. So number 3, why do you think it's important to algebraically check solutions obtained by looking at a graph? We did a lab a couple sections ago. Some of your zeros weren't quite accurate because your graphs weren't quite accurate. So us being human, we're going to make mistakes. Also though, even an accurate graph, your 0 might not be a whole number, and it's hard to tell with fractions and decimals. So, a couple reasons. Graph may not be perfect. Okay. Or the other thing, or exact enough. Maybe I don't have decimals or fractions on there. So we always want to plug those in to our equation and double check our solutions. So let's work through one example. We need to solve this equation by graphing. First thing to do is to solve it equal to 0 and turn it into a quadratic equation. That makes it easiest to graph. I'm going to leave negative 2x squared where it's at, and I'm going to add 8 to both sides. So now I've got negative 2x squared plus 8 equals 0. Back to my basics of graphing. The a value is negative 2. It's going to open down. It's going to have a maximum. It's going to be kind of narrow. The b value, there is none, so my axis of symmetry is my y-axis. My y-intercept is 8. So, axis of symmetry, y-axis, vertex is up at 8. Okay, I need some more points on here. Well, let's just go with 1 and negative 1. So I'm just going to check 1. Negative 2 times 1 squared plus 8. 1 squared is 1 times negative 2 is negative 2 plus 8 equals 6. So over here at 1, I'm up at 6. If that's 1 to the right of the axis, then I need to go 1 to the left of the axis and mirror that point. That's still kind of hard to tell what my shape is. Let's go ahead and do 2. Negative 2 times 2 squared plus 8. 2 squared is 4. 4 times negative 2 is negative 8 plus 8. Negative 8 plus 8 is 0. Oh my goodness. I think I've found my zeros. So I've already done my check inadvertently just by picking these points on my parabola and graphing. So it says solve by graphing. Well, I solved by graphing and I got x equals 2 and I got x equals negative 2. I don't even need to do the check because I've already done it. Now the question arises, what if I had added 2x squared to the other side and I got a positive a value that opens up? Guess what? same zeros. You get the same solution. It's just a flipped parabola. So instead of starting at positive 8, it would start at negative 8, and it would go up and go through those points of 2 and negative 2. Same solution. So really the only way you can tell when you're given an equation, a quadratic equation, whether to keep your a positive or negative is in a word problem with some reference to know whether you're looking at a parabola that's opening up or opening down. So get those two done. I'll check them tomorrow.